Okay, class, welcome to the first day of Unit 3, Topic 1. Unit 3 is Congruence and Similarity, and Topic 1 is called Congruence Theorems. Okay, we've used the word congruent before. Congruent is when triangles are going to be the same size and shape. So all corresponding sides and interior angles are going to be. So when triangles are congruent, that means everything is going to be congruent within that triangle. Okay? That means they're going to have the same size and shape, but they don't have to be all going the same direction. They could be mirror images, they could be flipped around, they could be upside down, they could be in many different ways. So when we're done looking at two triangles that are congruent, we're going to write something called a congruence statement. Okay? And the big thing with a congruence statement is that we need to match up the parts of each triangle when writing this statement. Is very, very important. So if you had triangle A, B, C, and triangle D, E, F, and they kind of look like they're the same shape and size, but we're going to show by making all the parts congruent. So I can go, this side here is congruent to this side here by putting one tick mark on each. This side here, BC, is congruent to this side here, EF, by putting two tick marks. And then AC, I'm going to put three tick marks. And DF, I'm going to put three tick marks. Okay, I also have to show that the angles are congruent. And so I have this angle here at A with one tick is going to be congruent to this angle here at D, which one tick. Angle here at B with two ticks is congruent to angle E with two ticks. And then angle C with 1, 2, 3 ticks, and angle F with 1, 2, 3 ticks. So when I'm done, I'm going to write a congruent statement, and the order that you write it is important. So I'm going to say triangle ABC is congruent, and if it's point A, point B, point C, they have to match up in order with the points that they match up with. So angle A matches up with angle D, angle B matches up with angle E, and angle C matches up with angle F. So triangle ABC is congruent to triangle DEF. And in congruent triangles, the two that are congruent, all their sides also have to be congruent. And all three angles have to be congruent. So we have the situation here where all three sides and all three angles are congruent. So when all the parts of two congruent triangles are congruent, we have a special saying called over here in the bottom right, corresponding parts of congruent triangles are congruent, or for shorthand I call C, P, C, T, C. You're going to see that a lot. It's basically saying this angle has to be congruent to that angle, and this side has to be congruent to that side. So imagine triangles are made out of cardboard, and they could be flipped around, rotated, as long as they're the same size and shape. They don't have to be in the same direction every single time. They just can be, any direction. So if you look at this, we have a triangle. We have three sides with one tick, two tick, three ticks. And over here we have one tick, two tick, three ticks. And we have to match things in order. So this congruent statement, it doesn't matter the order as long as you match. I'm going to call it PQR, the triangle on the left, is congruent to, well, let's see, angle P has one tick on it, and the one over here is angle L. Angle Q has one line on it with the tick through it, so that's M. And over here, it's N is the last line. R and N go together. And if I use my idea about that CPCTC, the congruent parts of this congruent triangle are congruent, corresponding parts of the congruent triangle are congruent, I have the sides and the angles listed below. So we're going to talk about how we can tell that two triangles are congruent without knowing that all 6 parts of them are congruent. A triangle has 6 parts, 3 angles, 3 sides. So how little of information do we need to know as possible to figure this out? So here are going to be different possibilities. Here are groups of 3 that will do. One is if you know all 3 sides are congruent to the other 3 sides, then obviously the 2 triangles are congruent. Second way is called side angle side, and we abbreviate everything. So side is called SSS. Side angle side is 2 sides and the angle in between, or what we call the included angle in between. Okay? It's the angle in between the 2. Angle side angle is 2 angles and the side in between the 2 angles, or ASA. Because here's the idea. If you know 2 angles, even though it says 2 angles, you know 2 angles, you really know all 3. Same thing goes for this next one, angle, angle, side. So angle, angle, side is no longer the side in between. It's an angle, another angle, and then the side that's not in between the 2 angles. And then we have a special one that we only use for right triangles called the hypotenuse leg congruence. That if it's a right triangle, it has to be a right triangle if you know the hypotenuse and one leg, not both, they are going to be congruent, because if you realize hypotenuse to leg, that means you know 2 sides, but you're going to know the 3rd side based on that theorem that we did before, because if you know 2 sides of a right triangle, you know the 3rd side. The #1 theorem of all time. On this page, I'm going to draw some triangles that fit the criteria of side, 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 or side, angle, side, or so on and so forth. So I drew a bunch of triangles with tick marks on the sides for matching sides, and arcs on the angles that are matching angles. And the very first one is side, side, side. And I kind of drew them purposely where they were flipped around. So you have to make sure you match the corresponding letters. So I'm going to do triangle ABC is congruent. Well, the side AB matches the side FE over here, so triangle FED. The second triangle, I'm going to do triangle RST is congruent to the triangle. Well, R has the arc on it, so it's going to be angle Z up to Y and then to X. Same thing over here, triangle DEF is congruent to, well, D has 1 arc on it, so that's triangle R. E's at the top, that's Q. The next one is P. Okay, then the next triangle, I have triangle ABC is congruent to triangle, well, A has 1 tick, so that's F. It goes up to B, which is a side, with E, and then to D. And this last one, the right triangle, triangle ABC is congruent to, well, A is over here on the one leg, triangle RST. So that's how we write congruence statement, making sure we're matching the corresponding parts of the 2 triangles. So this next page is asking, for the first one, which 2 triangles are congruent by the side, side, side theorem? So if I look at these 2 triangles, it has 1, 3, and 4 ticks on it. This one down below has 2, 3, and 4 ticks on it. And this also has 1, 3, and 4 ticks on it. So these 2 are matching up. And if I match up the corresponding parts, I could say triangle, it doesn't really matter, UVW is congruent to triangle. We'll use over here between the 1 and 3 ticks, and this is side EGF. Next one wants to do side angle side. That means two sides and the angle between. So over here I have 1, 2, and the angle between. And this one over here has 1 and 2 ticks and the angle in between. And I could call it triangle UTV is congruent to, let's see, U is on the side with 2, T is the angle with the arc on it. So the one with the 2 here is triangle S. R is the one with the arc on it, and then Q, matching up corresponding sides. This one wants to match up angle side angle. That means two angles and the side in between the two angles. If you notice, this one has an angle, a 2 tick, and another angle. This one has only 1 tick on it, and this is one that has the one with the 2 ticks. So these two, so it's triangle XYZ is the first one, is congruent to, let's see, X is like the peak that doesn't have any arc on it, and that's H. Y is over here with the 2 arcs on it, which is G, and then obviously it's I. It wants to do angle, angle, side. So that's 2 angles and a side that isn't part of it. Well, I see these right here. They're very much similar. These first 2 triangles. Angle, right angle, side, angle, right angle, side. So I would do triangle. Oh, there's a missing point here. Let's call this H. HFG is congruent to RSQ. Triangle RSQ. And this last one is going to be hypotenuse leg. And I have to find where, well, let's see. This is a hypotenuse here and a leg here that only has 2 ticks on it. And this one is the one with the 2 ticks on it. And I'm going to call them A, B, C, and then X, Y, Z. So I have triangle A, B, C is congruent to triangle. A is a right angle, so that has to be angle Y. B is between the 1 and 2 ticks, so that's Z, X. So this is how we write our congruence statement for everything that we do. So we've been talking about all these sides and angles and SSS and ASA and SAS and all this and that. So how about if we do side, side, angle? And a side-side angle does not work. It'll give you 2 different triangles. If you look at this first case, where they are congruent, that you have a side, and the angle that's not in between them, and you have it again, side, side, and the angle that's not in between them, and they are congruent here. So it could work, but we want absolutely that to work. So if we look carefully at this next case, this side BC is the same as this side QR, and then the side AB is the same thing as PQ, so we have side and side. And this angle here at A is the same as angle here at P, but there's no way that there's no way that these two are congruent. You can see that this angle R is obtuse and this angle C is an acute angle. So it does not work. It's kind of like it's hinged. It's like if you took this point here that should have been the congruent triangle and you hinged it in and swung it in, you could create that triangle. So SSA does not work. And then we could also talk about, how about angle, angle, angle? Well, if the angles are the same, should they be the same triangle? No. If all the angles are the same, these two have all the angles are the same, but they are clearly not congruent. They do have the same shape, and we'll talk about it later in this unit, but they are similar in size. They're not congruent. Similarity is something else, but the idea is that, it'll work out later. But when we want to use an angle or 2 angles, we have to know at least one side to give it some length, because obviously this side here and this side here are of different length. So let's see if we can prove that these triangles are congruent. And we notice we have a side here on the bottom and arcs on these angles. So by angle, side, angle, these are congruent, and I can say triangle ABC is congruent to, well, A is at the top, so triangle DB is the same as angle EF. Now, even though they get flipped around, we can see that we have a side, an angle, and another angle, or we could go angle, angle, side is the congruence for this. And I get triangle STU is congruent to, well, let's see, S is the side that is the angle that isn't marked, so that's J. T is the one with one arc, L. Now this one's a little bit different, because I think you need to pay attention though, even though it's not noted, this side GK is on both triangles. So it's congruent to itself. So if I look, I have a side here at the bottom, an angle, and another side, or two sides and the angle in between. I have the same thing over here. Two sides and the angle in between. So I have triangle HGK is congruent to, let's see, H is at the top with nothing. So N. G is the one arc, so K. And then obviously G. So let's use what we know to solve some problems. Based on this information that these two triangles are congruent, that means this side QR is congruent to HI. If you look at these letters, QR and HI, so it's 5x is equal to x plus 12, or x equals 12, x equals 3. And then over here, these two sides are congruent, so 10w is equal, and we solve for w, we get 4. This one's even more basic, is that, well, w is the hypotenuse over here, and 42 is the hypotenuse over here, so w is 42. And then 15 is his bottom leg, and x is the bottom leg, so x is 15. And there we go. So let's determine if these triangles are congruent, or how can we show that they're congruent? Well, I have this triangle here on the left and this triangle here on the right, and I see 2 ticks are matching, 3 ticks are matching, and this side that is common to both of them obviously matches itself. So I see 1, 2, 3 ticks here, and 1, 2, 3 ticks here. So by side, 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 it is congruent. Over here I have the same idea, that this common side is congruent to itself, and therefore we have 2 sides and an arc angle in between, and 2 sides and an arc angle in between, so it's side, angle, side in that order. On this triangle, this is a right angle, this is a right angle, so I have the hypotenuse of this one with 3 ticks, and the same thing here, so this is hypotenuse leg. And these angles here, I'm going to put 2 arcs on them, are congruent because they are vertical angles. So the one on the lower left side is a angle side angle, and this one is also an angle side angle. See, I just read things in order. So it's asking me to show what else needs to happen to get angle angle side. So I have angle X, angle A is congruent to angle X. So that's right here. A is congruent to X. Angle B is congruent to angle Y. So angle B is congruent to angle Y. And when I do angle angle side, it is 2 angles and the side not in between. So here are the 2 angles. AB is in between here and XY is in between here, so I could use any other side. I could do AC. I could do AC is congruent. Oh, that's terrible. Is congruent to XY, or I could have done BC NYC, because they're not in between the two angles that we show congruence. And I should, for angle B and Y, put 2 arcs on them. The next one we're going to use angle side angle. That means 2 angles and the side in between. That's why the S is in between the 2 A's. Angle A, again, angle X. Side AB, which is right here, is congruent to side XY, which is here. And I need another side. Well, if I go with BC, that's not going to be kind of making a sandwich out of that angle. So it's going to have to be this side and this side. Angle, side, angle. 1 tick, arc, 2 ticks, angle, side, angle. So I had to show that. I'm sorry, I'm doing this wrong. Let me start again. I'm doing side, angle, side. I'm not paying attention. Let me start all over. I have this. Angle, side, angle is 2 angles and the side in between. Well, I have an angle, I have a side. I need another angle that will make a sandwich of the side. So I have to do an angle here and an angle here, because now I have my whole situation of angle, side, angle, angle, side, angle. So I had to show that angle B was congruent to angle Y. That's what I needed. That was my bad. I'm going to make mistakes. I'm not perfect. And then finally I want angle, angle, side. Going back to what I did before. And I have side BC, side YZ, angle C, angle Z, and then I have 2 sides. I need another angle that is not connected to that side. So that would have to be up here. That angle A is congruent to angle X. So now I have, if you go in order, I have angle, angle, side. Angle, angle, side. So this last page is asking what else is needed to be able to show the congruence by the given statement. So this one is hypotenuse leg. That means I have to have a hypotenuse and one of the legs congruent to the hypotenuse and a leg on the other triangle. Here's my right angle here, my right angle here, and this side RQ and this side QY are next to the right angle. That means they're a leg. So I need across from the right angle, known as the hypotenuse. So I need RS to be congruent to XY to be able to use the hypotenuse leg congruency. Angle side angle is 2 angles and the side in between. So I have an angle side and I need an angle here. And I have an angle side, so I need an angle here. So right now I have angle, side, angle. Angle, side, angle. I could say, so I had to show that angle S was congruent to angle B. Over here I want side, side, side. Well, I have 2 sides. I could just pick the third side, and I needed to know that side WU is congruent to side FD. And side angle side, well, even though it's not obvious here, we know that IJ is congruent to itself, so I need the angle in between. So here's a side here, here's another side. I need this angle in between. So I need this angle here, I need this angle here, and because there's a couple things going on at that vertex I need to show that angle GIJ is congruent to angle, that's a HIJ. And there we go. Thank you for watching this video, and ask questions.